Huh. So what is the doubt?
The third question in 3.2.
You can see the screen, right? Okay, you cannot see it. I'll share it. Module is which question? Third
Yes,
one.
sir.
The correlation between two variables is plus 0.25. The most appropriate way to interpret this value is to say the scatter plot of the two variables is likely to show a strong. It is not strong because plus 1 and almost 1 is very strong. So it is not a strong linear relation. When one variable is about its mean, the other variable tends to be when one variable is above its mean, the other variable tends to be above its mean. Yeah, a change in one of the variable usually causes the other variable to change in the same direction. Okay, so
So
a
B and
change in
C mean the same thing, right?
no.
That
See, when one variable is above its mean, the other variable, so it is talking only about mean. It is more focused talking about mean, and that's not what plus 2 point is indicating. It is just indicating that they move in the same direction. It should be C. Just check.
they've given B.
Okay, what is the answer then? Let me see. 3.2, third question. Okay, B indicates positive linear relationship. One tends to be above its mean when the other is above its mean. The value 0.25 indicates that the linear relationship is not particularly strong. Correlation does not imply causation. The change in one of the variable, acha, okay, this is the problem. This is where I made mistake. Causes the other variable to change in the same direction. That means it is the reason. Cause as in reason. Okay, so
Okay, so
not the reason.
do they mean that the two variables are dependent on each other?
Yeah.
Okay.
Okay. Changes in one of the variable usually causes the other variable to change. Okay, so this is okay. Causes. When one variable is above its mean, the other variable tends to be above its mean. Change in one of the variable usually causes the other variable. So correlation is not the causation. Yeah. Okay. That's it. What is the other doubt?
So can we do the
That's it.
module quiz for the fourth module, 4.1? Hello.
Can you hear me?
Yes, sir.
Which module quiz you said?
The fourth module, 4.1.
This one. No? Have you done this sum? From here we are supposed to begin today, right?
The example?
This one have you done?
Yes, sir. I understood that. But we can do it again once.
So we'll do it this one now. See.
So your screen share is off.
Okay. Okay, just give me a minute. I'm not able to write it 1 minute. Okay, I think some blue sky. Ah, hello, can you hear?
Yes, sir.
Yes, sir.
So this based on these statements, this tree has been formed. So there is 60% probability that the economy will outperform, and if it does, there is a 70% probability that the stock will go up. That means 60% is unconditional.
So
60%
screen share is
probability
off.
that the economy will outperform. Probability of economy outperforming.
So your screen share is off.
Hello.
So that
No.
means 40% probability that the
So
economy
your screen share is still off.
underperforming. Okay, underperformance.
Hello. Hello. Hello.
Then if it goes up by
Sir, am I
60%, there is
audible?
70% chance that the stock will go up.
Hello.
Hello. I
70%
guess sir is
chance
not able to hear
that
Yeah.
us.
the stock will go up.
Can you call him?
Yeah, I'll call.
That means 30% chance that the stock will come down. Then there is 40% probability the economy will underperform. Okay, this one. And if it does, there is a 20% probability that stock in question will increase in value. Okay, just 1 minute.
Sir is reconnecting.
Okay.
You're a
Hello,
college student or you're...
can you hear me now?
Yes, sir.
Yes,
You
sir.
can hear me now.
Yeah.
Okay.
So your screen sharing is off.
Huh.
Yes, sir, visible.
Huh. Okay. So based on this, I'm drawing all this. Okay. So based on the question, so 40% probability that the economy will underperform, and if it does, there is 20% probability that the stock will question, it will increase in value. So 20% that the stock will go up. This is stock down, and 20% probability that the stock will go up. That means 80% probability that the stock will come down. Okay. Given that the stock increased in value, calculate the probability that the economy outperformed. Given that the stock increased in value, that means we are making this as what? Independent. So when we are making this independent, we have to first of all find out what is the independent probability of stock going up. Okay, so let's calculate that first. Okay, so independent probability. So I'll write here. Independent means unconditional. Okay, let me write unconditional probability of stock going up is what? So what is the unconditional probability? Like stock goes up based on economy outperformance, or stock going up economy underperformance. Both if I include, now I don't care economy is outperforming or underperforming, I have included both the sides stock going up. So it will be 70% into 60% or 20% into 40%. So that is 42% plus 8%. So 50%. Is this okay?
Yes.
Okay. Similarly, if I want to know the unconditional probability of stock coming down, so let's do that as well.
Coming down.
Unconditional probability of stock coming down will be what?
16 to 30 plus 14 to 80.
These two and
18
this
plus
two.
30, 50%.
30 into 60% or 80% into 40%.
So 50%, right?
Yeah, it will come to 50. Those are 32. 50. Okay, so both are 50-50. So now the question that they have asked is calculate the probability given that the stock increased in value. Okay.
So it means the stock goes up.
Hmm. Given that the stock increased in value, given that the stock increased in value, um,
So
calculate the probability that the economy outperformed. Calculate the probability.
it will be 60 into 70 upon 50 आएगा उसका. हाँ, 60 into 70 upon 60 into 70 plus 40 into 20.
Okay, calculate the probability that the economy outperformed. Yeah, given that the stock increased in value, so that means, okay, unconditional, given that is increased in value, so unconditional probability of increase in value, stock increase in value, which is what, 50 percentage, 50, or you take this entire thing, this is much better, 70 percentage into 60 percentage, so that
Plus
you know
20
that
into
the
40.
answer, yeah, the answer has to come from this one only. Okay, then now this is 50 percentage. Now calculate the probability of economy outperform. So economy outperform is here. Okay, and stock going up, right? So this part 60 into 70. So this is here 70 percentage into 60 percentage. Is it okay? Understood
84%.
this one? Overall, how much
Yes,
is it
sir.
coming to?
84.
Okay, it's matching 84 percentage. Fine, okay. The next
Yes, sir.
one,
So 16%.
outperformed, underperformed. Underperformed. So given that the economy increased in value, so that means denominator is 70 percentage into 60 percentage plus 20 percentage into 40 percentage. So economy underperformed. Economy underperformance this, and stock increased in value. So 40 into 20. That means this part 20 percentage into 40 percentage. Just calculate this.
So 16%.
Okay, the next one, given that the stock decreased in value, calculate the probability that the economy outperformed. Given that, first we'll write this one. Given that the stock decreased in value, outperformed. Let's say outperformed. Economy outperformed. So now what is the answer for this? So first of all, given that the stock decreased in value, so I will take unconditional
64%.
probability. Unconditional probability of stock decreasing.
So
30%,
50%.
yeah, into 30% into 60% plus 80% into 40%.
40.
Now calculate the probability that the economy is outperforming. Economy outperformed
16 to 30.
is
Yeah.
here 60 into 30. That means this one 30% into 60%.
60%. So it will be.
Calculate
So the
36.
final answer will be 36. Yeah.
36%. Okay. Then next one. Given that the stock decreased in value, calculate the probability that the economy outperformed. That the economy now underperformed.
Yeah. And so 64.
Underperformed.
So 64%.
Huh. Given that the stock decreased in value, so decreased in value is this one 30 into 60% plus 80% into 40%. Given that the stock decreased in value, calculate the probability that the economy underperformed. Underperformed is here. Decreased in
40
value.
into 8.
40 into 80. Or 80 into 40. Calculate this.
64.
Understood? This one is okay now?
Yes.
Okay. The next one. Have you done this one, module quiz?
No, sir.
Shall I do now, module quiz?
Yes,
You
sir.
tried or you didn't try only?
Didn't try, sir.
You didn't try? Okay, then just take a minute. Try now. I don't think you will be able to do,
Okay.
but you try. If you are doing it, is very good. If not, anyways,
Okay.
I will be doing it. Just take a minute and try.
Okay.
So done.
Done.
So can you solve this one?
Yeah. Okay. See, given the conditional probability in the following table and the unconditional probability. So this is the unconditional probability. This is the event. Y is equal to 1. So this they have given in numeric form, so it tends to confuse us. So this is probability of y equal to 1. This is probability of y equal to 2. So probability of y equal to 1 is 30%. Probability of y equal to 2 is 70%. This step is okay.
Yes.
What is the expected value of x? Now all these are what? These are all conditional probability. So conditional probability means probability of x1 given y is equal to 1. That means this is probability of y equal to 1. So in this case, probability of x1 given y equal to 1 is equal to 20%. This is 20%. Then they are saying, see this 20, 40 and 40, total 100%. So it is coming up with 3 nodes. First one is 20%. Then probability that okay, so the conditional probability of x1, probability of x1 given y equal to 1 is 40%. That is also there.
Sir?
Huh?
No, sir. Continue.
Probability of x1 given y equal to 1. Okay, so that is 40%. And then the probability of x1 given y equal to 1, this is another one, 40%. So it is taking 3 nodes. So if it goes this way, first way, x1, okay, the value of x1 is 0 in this way. Here it is 0. And then here it is 5. And here it is 10.
Sir,
Huh.
if we make the branches for y is equals to 2 as well,
Huh.
then I guess it will be easier to explain. So we can show the addition of that 0, 5 and 10 probabilities.
Okay. So this one will be probability of x2 given y is equal to 2, which is equal to 10%. And probability of x this is not x2, it's x1 when y equal to 2, this is 80%. And here also probability of x1 when y is equal to 2 is 10%. So even here also 0, 4 and 4, no, 0, 5 and 10. This is the tree. So it is difficult to get confidence on the tree. Once you form the tree, then it is easy only. What is the expected value? So expected value, average value is, no, this is 0. Zero's probability is what? 50 percentage? No, 60. No, 6 percentage, right? 30 percentage into 20 percentage is what? 6 percentage, right?
6, yeah.
6,
6 percentage. Or means plus. Then 30
7.
percentage into 40 percentage is 4 threes are 12, no? So 12
No, so that
percentage.
is not the probability of 0, right? The probability of
This is
0
0.
will be 6 plus 7 percentage. 70 into 10.
6 plus 7.
So
Okay, here,
probability,
no. We are
yeah.
calculating entirely all overall expected value of x. Okay,
Okay.
so wait. So this will be 0 plus this will be, how much is this?
12% into 5.
5 percentage. How did I?
So it will be
No.
6 only.
This is 4 threes are
Yeah, that is
x.
12%, and 5 is the value of x.
5 is the value of x, and that is 12
Yeah,
percentage. Yeah, so 12 percentage of 5.
6.
yeah,
6.
6.
Then plus this will
So
be
point, so it will be 0.6, right?
4 threes are 12 again, right? 12. Is it? It will be 0.6.
So
No?
0.6.
Yeah, 0.6. Then 10 into 12 percentage.
1.2.
Then 0 into
0. So this will be
this
0
part.
only, no?
Yeah.
Whatever value it.
Yeah.
Point,
But still,
7. 7 percentage.
7 percentage. 7 8s are 56.
56.
How much?
0.2. 2.8. 2.8.
This is 70
Into 10.
and 77
7.
percentage.
7 percentage. 0.7. If we add this, we get 5.3. Should get
How much?
5.3.
Just check the answer also.
Yes, sir.
4.1
Yes, sir.
matching.
5.3.
Is it okay?
Yes, sir.
Yes.
The next one. You want to try the next one? Next one should be fine only. Try.
So 70%.
Okay.
Yes, sir, got it.
You did?
7%.
Yeah. Okay. Portfolio management. Okay. Yeah. Portfolio management. Here, covariance. Now we have already done this, right? So just read this one, first part. Right? This paragraph.
Yes.
Okay. The following are the properties of covariance. Um, so you see here, they have not divided by n minus 1. That is because expected means probability is included in it. Okay, now here the point that they are making is covariance of an asset with itself is equal to the variance of the asset. Covariance of an asset with itself will equal to the
Is this applicable only when probabilities are included?
which one? This one?
Yeah.
No. Otherwise also, yeah. Covariance of an asset with itself is equal to the variance of the asset. What does this mean now? See, covariance of x comma y is what? Summation of x minus x bar into y minus y bar divided by n minus 1.
Yes.
Now, if I replace y with x only, then what will happen? Divided by n minus 1. Okay, I'm replacing y with x. Summation of x minus x bar the whole square divided by n minus 1. Now, do you recollect anything seeing this
Standard
formula?
deviation.
Variance.
Variance.
If
Yeah,
I
sorry.
put root, it becomes standard deviation. Now it is variance. So that's why covariance of x comma x is equal to variance of x. Understood or not?
Yes, sir, understood.
Okay. It's the derivation. So covariance of returns from asset A comma returns from asset A is equal to variance of returns from asset A. Okay, covariance may range from negative infinity to positive infinity. Any number it can be. Okay, see this kind of questions they like asking. Okay, so these theories are all important, very important one.
Okay.
Acha, here is the one. See that we did na sometime back.
Yeah,
Positive
right.
covariance is above its mean. The other random variable is also okay. A positive covariance indicates that when one random variable is above its mean, the other random variable also tends to be above its mean. So on an average mean point of view, okay. Same case for we read about correlation. Same case even for covariance. Then sample covariance. So yeah. Now this sum we have to do. Covariance matrix. Yeah. Okay. The diagonal terms from left to from top left are the variances of each term. Okay. This I'll explain. We'll do this sum, then you will understand all this. Okay. So I'll write this formula now. You can read from here. Okay. Till here.
Okay.
So domestic stocks 60%. Domestic bond international equities. So 400, then 44, 180, 44, 70, then 180, 35, 450. So what do we have to find out? We have to find out variance of the portfolio or standard deviation of the portfolio. So before we solve this sum, let's build some foundation. See, standard deviation is equal to what? Standard deviation of an asset or standard deviation of X is equal to root of summation of X minus X bar the whole square divided by N minus 1. Okay, this is the formula. And this is for one asset X. Now if I say what is the standard deviation of the portfolio of two assets? Okay, two assets. So standard deviation of the portfolio is equal to what? Root of summation of not summation, root of weight 1 into standard deviation 1. Okay, first one, weighted average, right, kind of thing, plus weight 2 into standard deviation 2 raised to 2. Have you understood this one?
Yes.
Okay, so this is first part and then this is second part. So this is actually variance, but this is variance, so I'm taking root, so it becomes standard deviation. Okay.
Okay.
But is this enough? It is not enough. Why? Because it is weighted average only. Why it is not enough? Because when two assets are coming together, there will be correlation between them. So say for example, A and B are friends and they are sitting in one room and studying. So what will happen? If A is studying for 2 hours and B normally studies for, let's say 1 hour. Now together they will not study for 3 hours. They will study for more than 3 hours possibly. Why? Because when B thinks that, oh, A is studying for 2 hours, I will also study for 1.5 hours then A will also think that, okay, no, I have to be ahead. I will study aggressively for 2.5 hours then. So it is the correlation between them which is making them to study for more. So similarly, because of one asset, second asset will move. Because of second asset, first asset will move.
Okay.
So that is called correlation. Okay. So because of the correlation, so that means twice this correlation is happening, plus 2 into weight 1 into standard deviation 1 into weight 2 into standard deviation 2 into R. So it is like weighted average correlation between them. Fine with this formula. Very
So
important one. Okay.
the first part is standard deviation and the second part is correlation.
Yeah, because of the correlation. Correct.
Okay.
Okay. So now I can further rewrite this formula as root of, but this formula is important. You have to know this one. Okay. But there is one more formula also. So that formula is weight 1 into standard deviation 1 square plus weight 2 standard deviation 2 square. Okay.
So it is
Plus,
basically based on the variances, right?
yeah. Okay. Plus now, did I tell you the formula for correlation? Correlation is equal to what? Correlation is, yeah, we did last time.
Covariance. Yeah.
Divided by.
Upon standard deviation of X into
Standard
standard
deviation.
deviation of Y.
Okay. So now weight 1 standard deviation of 1. 1 means X. Okay. Into weight 2 standard deviation of 2. Into, now correlation means what? I can say 1 comma 2 divided by standard deviation of 1 into standard deviation of 2. This is okay. So this and this gets cancelled. This and this gets cancelled. So okay. Two into weight 1 into weight 2 into covariance of 1 comma 2. This is the formula. This formula also you should know. It's not that difficult. It looks scary, but once you understand the logic behind it and then practice, it will be all right only. Okay, this is standard deviation of portfolio of two assets. Is it okay? Fine. Just take a minute, look at this and ask me if you have any questions.
So if there's three assets, will it still be 2 into weight into the standard deviation, or will it change to 3 into the
Okay, now
weight
let's,
into?
okay, now that is the next one. So standard deviation of portfolio for three assets. See, if I remove this root, it will become variance of portfolio, okay? If I remove this, this root, it will become variance of the portfolio of two assets. Now for three assets, we'll see standard deviation. Root of, now there are three assets, 1, comma 2, comma 3. So weight 1 into standard deviation 1 square, weight 2 into standard deviation 2 square, plus weight 3 into standard deviation 3 square. First part is okay.
Yes.
Plus now 2 into, so between one, see, correlation is always only between two parties only. It will not be between three. So it will be one between 1 and 2, 2 and 3, and then 3 and 1.
Okay.
Okay, so 2 into weight 1 into weight 2 into covariance 1 comma 2. Okay, plus 2 into weight 2 into weight 3 into covariance 2 comma 3, plus 2 in weight 3 into weight 1. Weight 1 you take first or weight 3 you take first, that doesn't matter. Covariance 3 comma 1 or 1 comma 3. Okay. You understood the formula?
Yes, sir.
Okay. So this is what we are going to do now for three assets. Okay. Is it okay? Till here it is fine, right?
Yes, sir.
Okay, now you see here. Okay, so here, now I just have to plug in the number. Okay. So first one, so I need to find out the, what do I have to do? I have to find out the variance of the portfolio, or in other words, if I remove this root, it will become variance of the portfolio. Okay. So variance of the portfolio or standard deviation of the portfolio. Okay. So variance, okay, or standard deviation, okay, standard deviation of the portfolio of three assets is equal to Now root of, okay, root of weight 1. So weight 1 is how much? 60, 30, 10. Okay, these are the weights. So 60 percentage into standard deviation 1 is what? Standard deviation is C. This is covariance and covariance. So covariance and covariance of the same asset will give me what? Variance. So
Yes.
this is basically, this is covariance matrix. Okay, this is covariance matrix. See, covariance matrix for 3 assets. So now covariance of domestic stocks with domestic stock is 400. That means, can I say it is the variance of the domestic stock 400?
Yes.
Right. If
Yes.
this is the variance, then what is the standard deviation of domestic stock? If this is the variance, then what is the standard deviation? Standard deviation will be root, no?
Yes,
Root
sir.
of variance is standard deviation. So root of 400. What is root of 400?
20.
So 20. That's its square. Is it okay? Understood this step?
Yes, sir.
Okay. Plus weight 2 into standard deviation 2 square. So what is weight 2? Weight 2 is 30 percentage. So 30 percentage into, can you tell me what is then standard deviation? How do I check now? Standard deviation for the second one. Second one is domestic bond.
So 70.
70 is root. Correct.
Variance, yeah.
70 is the variance. So take root of 70.
8.36.
8.36 is the standard deviation square. Plus next one is 10 percentage into root of what?
This is 21.21.
450, correct? Root of 450. 21.21. Okay. Raised to 2. Then plus, I'll write here, plus weight 1, 2 into weight 1 into weight 2 into covariance of 1 comma 2. So 2 into weight 1 is 60 percentage into weight 2 is 30 percentage into covariance of 1 comma 2. So what is the covariance of 1 comma 2? This is 1, this is 2, this is 3, or this is 1, this is 2, this is 3. So what is 1 comma 2?
44.
44. So you see whichever way you want. See, this is 1 and 2, 44, or this is 1 and 2, 44.
Yes.
So 44
Sir,
plus,
covariance is like the common number.
yeah, because it is covariance matrix, no?
Okay.
Plus 2 into, then weight, no? This is 2 and 3 weight. So this is 1 and 2. So 2 and 3 is what? 30 percentage into 10 percentage. Into what is the covariance of 2 and 3 now?
180.
2 and
2 and 3. Yeah.
no, 2 and 3 is 35.
35. Yeah.
35 plus 2 into 3 and 1. 3 is 10 percentage into 1 is 60 percentage into 3 and 1. What is the covariance?
180.
180.
So now you just calculate this, keep it in store 1. Store 1, store 2, store 3, store 4, store 5, store
Sir,
6.
the first one is 60 percentage into 20, right?
Yes, and raised to 2.
144.
144 is what? Only this number?
Yes.
Okay, so root of 144 plus
6.29.
plus
4.49.
plus
15.84.
plus
2.1.
Hmm.
21.6. 13.94 is the answer.
root you have taken.
Yeah, 13.94.
Okay, 13.94 is the standard deviation. If they would have asked variance, you have to remove root.
Yes.
Ah. Is it okay now? So this is, so now you just have to practice this. This is the formula. Okay, you don't have to go through all these formulas now. What we have done is enough. Another part is you can read this theory. These are the units of variance and covariance. Is what? Percentage square. That is 0.001. We can get the numbers in decimal, basically they are saying, but it is percentage square. Okay.
Yes, sir.
Can you understand this one? They like asking this kind of questions. Okay,
So
just
which one?
this part. Okay, I'll connect my charger to the laptop. 1 minute.
So is this because covariance into covariance is equals to variance? So if the covariance is less, ultimately the variance will also be less.
Yeah. See, it is because, see the formula. If this covariance is less, this entire part will become less.
Yes, yeah.
That is the reason.
Okay.
See, these formulas you have to remember, write it down. In some, I told you to keep one rolling whiteboard paper. Have you bought it?
I have a whiteboard only. Yeah.
So you write there. Plus, you may get also more whiteboard rolling one. So this will be very convenient to hang it on the wall. Multiple uh, rolling whiteboard paper, I would say you buy, because when I used to do, I remember buying like 6, 7 rolling whiteboard paper. So front, back, both the sides I used to write, and then just hang it to the wall. So every day I will keep looking at it. So it will be easier to, automatically formulas will go into the head. You don't have to sit specifically for this and try to remember them. Okay.
Okay.
So these formulas all always should be there in front of your eyes. That way you create the environment. This we have already done. Correlation is equal to covariance by standard deviation of A into standard deviation of B. That is okay. So it is just, then that creates another formula. See, correlation is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. So on this basis, I can say covariance of x comma y is equal to what? Correlation
Correlation
into
into
standard
standard
deviation of
deviation of x into standard deviation of y.
this also you should know. Okay. Yeah, these acid themselves are all one. Okay. So that means correlation of domestic stock with domestic stock is 1. Is that okay?
So screen share is off.
Correlation of an asset with itself is 1.
Hello.
Hello, sir.
I don't think you can hear us.
Yeah, wait, I'll call it.
Achha.
Sir is rejoining.
Okay.
Are you graduated?
Yeah, I just graduated this year.
Oh, from?
You?
Yeah, I also graduated this year.
You can see the screen. Correlation of an asset with itself is 1. Is it okay?
Hmm.
Okay. So now we'll continue. Okay. Just go through this question now. Read till here. right?
Yes, sir.
So this is the table, okay, based on which we are supposed to do now, right? See, this is all written. See how the table how you are supposed to read. Return of asset A is equal to 20 percentage, okay, and the return of asset B is 30 percentage, and the probability of this two happening is 30 percentage. Then return of asset A is 12 percentage, and the return of asset B is equal to 10 percentage, okay, and that probability is 50 percentage. Then return of asset A is equal to 5 percentage, and return of asset B is equal to 0 percentage, and that probability is equal to 20 percentage. Okay. This is the question. Now what do we have to calculate? Calculate the covariance of asset A and B. So covariance normal formula is what? Normally A and B or X and Y is equal to summation of X minus X bar into
Y minus Y
Y
bar.
bar by N minus 1.
Hmm.
But because probability is given, that means this N is taken care of already. Okay, so we just have to multiply with the probability. So that means, first of all, what is X bar and Y bar? So how will you calculate? How will I calculate X bar and Y bar? X means you take A, Y means B. So X bar is equal to what? So either this one or this one or this one. That means 20 percentage of 30 percentage or 12 percentage of 50 percentage or 5 percentage of 20 percentage.
6, 6,
Hmm.
and 1. So 13.
Overall comes to 13 percentage.
13. Yeah.
Similarly, Y bar is equal to this one or this one or this one. Into 30 plus 30 percentage. How much is this?
14.
Okay. So now, yeah, X minus X bar. So X is what? 20% minus 30 percentage, and its probability is X minus X bar into Y minus Y bar. Y minus, so X minus X bar and Y minus Y bar. 30 percentage minus 14 percentage.
So it will be 20
20
minus
minus
13%. Yeah, 13%.
20 minus 13. Acha, this is 13. Into 30 percentage minus 14 percentage. And its probability is what? 30 percentage. Or, so just you have to practice this one, okay? Otherwise it will go out of the head. Otherwise, okay, then 20 I have done. Now 12 minus 13. 12 percentage minus 13 percentage and 10 percentage minus 14 percentage. And its probability is 50 percentage. Okay. Plus third one, 5 percentage minus 13 percentage into 0 percentage minus 14 percentage and its probability is 20 percentage. Calculate all this now. So when you calculate percentage, how you should calculate is when there is, when you want to add or subtract percentages, ignore percentages. So 20 minus 13 is what? 7. So 7 and then you suffix with percentage. 7%. Otherwise, if you just simply type 20% minus 13%, you will get wrong answer. It will deduct 13% from 20% then. Okay. So 7 percentage into this is 16. 30 minus 14. 16 percentage. Okay. So first you calculate this part. Tell me how much is it coming to. First part.
0.36%. 336. Yeah.
Second one.
Point 0002.
Percentage, right?
Yeah.
If you, Shravani, if you get another answer, you let me know so that we can cross check here itself.
Point 000224. Sir,
The
yeah, okay.
first one will be 0.00336.
So we should remove the percentages like I and Shravani, we both have done after removing the sign. Yeah.
I can write in this way also. It is fine. 0.336. Okay.
0.0058. The total answer.
Second, so first one is correct only for both. Second one is
Yeah.
what? This is
It's
okay.
correct. Yeah.
Third one, is it percentage after taking percentage or before?
This is before taking percentage. So we have to remove the percentage basically.
Okay, 0.0244. That means.
No, so I meant to remove the percentage sign.
Okay. No, but I have to standardize now all.
Okay.
So I'll write this as 0.0224 percentage. So this is zero. This is what? 0.02 percentage, is it? Or 0.0002
So I believe we
percentage?
should just lose the percentage sign. So it should be 0.02 percentage if we have to write it that way.
Wait.
Because when I was calculating, I considered 4 percentage as 0.04. So
Oh, so you got this one number, right? So that means
yeah,
0.02 percentage.
yeah.
And this is
So it's
0.
confusing, sir. Above you have in the first one you have written without percentage. In second one you're writing with percentage.
Okay, let me also do that. Wait. First is this is 7 percentage and this is 16 percentage into 30 percentage. So 7. Okay, I'll do it in front of you only. So 7 percentage into 16 percentage into 37 percentage into 16 percentage. I think this is not working. So problem. Okay, I'll do it in my calci only. Calci. So 7 percentage into 16 percentage, okay, equal to 0.0112 into 30 percentage. So I got 0.00336, which I can convert it into percentage. So I will write this as 0.336 percentage, first one. Okay, I'll keep it in store one. Okay, then 12 minus 13 is minus 1. So 1 minus 1 percentage into this is minus 4 percentage. So okay, 4 minus percentage, okay, into 50 percentage. So this, if I convert this answer into percentage, 0.02 percentage, 0.02 percentage. Okay, I'll keep it in store 2. So I'm getting answer without percentage only, decimal. I'm only multiplying by 100 and then converting it into percentage. Third one,
Okay.
yeah. Third one is minus 8 percentage into minus 14 percentage. So anyways, minus I don't have to care about, it will go away. So 8 percentage into 14 percentage into 20 percentage. So now I got 0.00224. I will multiply by 100 to get percentage. So 0.224 percentage. And I will store this. So now recall 1 plus, no, 1 minute, recall 1. So I will add recall 1 plus recall 2 plus recall 3. And then, so I'm getting, because I'm just writing here as percentage, but otherwise in the calci I did not take percentage. So I got this one, which means 0.58 percentage. Yeah, 0.58 percentage. It is in decimal, which is fine. I can write this as 0.0058. Is it okay?
Yes, sir.
Criteria. Okay, Roy's safety first criteria. You should know this theory. Shortfall risk, the probability that a portfolio value or return will fall below a particular target value or return over a given period. Okay. Roy's safety first criteria means what? So this is a simple one only. See, there are certain formulas. Sharp ratio. Sharp ratio means this you will find in another other subjects also, very important one. Sharp means is the name of the guy who came with this ratio.
Hmm. Won the Nobel Prize.
Portfolio minus risk-free rate divided by standard deviation of the portfolio. Okay. So that means what do you learn from this formula? It will tell you the excess return for per unit of risk. Excess return for per unit of risk. Excess return for per unit of risk. You want this ratio to be higher or lower?
Higher. Higher.
Okay, I'm
Hello.
not able to hear you.
Sir, higher. Are you able to hear me?
Yeah,
Sir, hey device का issue है. You're from which college?
St. Xavier's.
Churchgate.
हाँ, CST वाली.
Hello.
Yes, sir. You're audible.
So you want that ratio to be higher or lower?
Higher.
Sharp ratio. Yeah. Okay. Yeah.
Sir,
Similarly,
for the
there is
Roy's
another one.
SFR, sir, for the Roy's SFR, we'll need to do that chart and the other one also, that appendix.
Not for SFR, another one that I will do next time only. That will be time
Yeah.
consuming. But SFR, I'll just quickly finish. Roy's safety
Okay,
first
sir.
criteria. Safety first SFR ratio
Ton of portfolio.
is equal to return of the portfolio minus, instead of, if you want to know, instead of risk free, some other threshold that you are keeping, you want to know how much more than 10%. So let's say that is the minimum threshold for you. So that is called threshold level. They are writing threshold level return divided by standard deviation of the portfolio. Okay, Roy's safety first. So beyond the threshold level, how much excess return you are getting? Just read this question. So it says, or safety first criteria. We'll just finish one part, okay, and then I'll leave you, okay. Roy's safety first criteria. Now just go through this question. It will not take time for this Roy's safety first criteria.
Yes, sir. Done.
Okay. See, now what is the threshold level? You have 120, you want minimum 123.6. That comes to what?
3.6 by 120, 3%.
that is 3%. So minimum you require 3% return, and rest all are given in the question. Actually, they have given it in answers. It should have been given in the question itself, not in the answer. But the actual question should be, like this table should be a part of the question. Like here. Okay, so you think it is all these are question A, B, C, and expected return of the portfolio is 9%, 11%, and 6.6%. And standard deviation of the portfolio is 12%, 20%, and 8.2%. Okay. So this is a given condition, and threshold is you require minimum 3%. So safety first criteria or safety first ratio is equal to 9% minus
3%.
3% divided by
Upon 12.
12%. Calculate this.
0.5.
Okay, that means per unit of risk you are getting extra excess return over the threshold 0.5 rate for 0.5. Similarly here 11% minus 3% divided by 20%.
0.4.
And here
4.4.
yeah, how much?
4.4. 0.44. Sorry.
0.44. So which one will you select out of these three portfolios?
0.5.
This portfolio you should select. Shravani, you understood this?
Yes, sir.
This is called Roy's safety first ratio. Okay. Now this sum has another part also that we will see next time. That is a lengthy one, little time consuming and little hectic also. All about hypothesis related stuff that we'll do next time. Okay, we'll stop now here.
Okay, sir. Thank you, sir.
Okay, bye.
Thank you, sir.
Bye. Bye. Bye.